Welcome to solverfy.
All right. So for this problem, we know that we have a reaction from uranium to the two elements. Let me see. The two elements are uh, this one and this one. So for part A, we want to know by what percentage the area is changed. So basically, this percentage is delta S over SI. So SI is the initial surface area, which is the surface area of the unit of the uranium atom, and delta S is defined as SF minus SI divided by SI. So SF is the final surface area, so which is the summation surface area of these two elements. Okay. So we know that for the for the sphere, S equal 4 pi r squared, right? So this is proportional to V with the power 2 over 3. And this is also proportional to the mass A with power 2 over 3, right? So on the left hand side, we have this expression. This simply becomes AF 2 over 3 minus AI 2 over 3 and divide by AI 2 over 3. Okay. So you can look up the total mass of the uranium and the total mass of these two elements. And you can find out this value is 25%. So we can see that the total surface area is increased by 25%. And for part B, we want to know the change of the volume, delta V over VI. So delta V is VF minus VI and divided by VI, okay? And we know that V is basically proportional to the area, to the total mass. So this is just the AF minus AI divided by AI. And we can see that AF minus AI in this process is 0. So this is 0. So it means that the total volume does not change. And for part C, we want to know by what percentage the energy is changed. The potential energy is changed. So the potential energy for the atom is given as U equal 3 over 5 Q squared over 4 pi epsilon naught times R. So as we can see that this is proportional to Q squared times A with power negative 1 over 3. Okay. So delta U over UI in this case becomes UF minus UI divided by UI. So UF is UF is the final state, which is Q this element squared times A this element with power 1 over 3. 1 over 3, yeah. And plus the other one, the other element, which is Q this element times A this element with power 1 over 3. So we have these two. And divide by, so the numerator becomes the potential energy of the initial uranium atom, which is Q U squared times A U with power negative 1 over 3, okay, and minus 1. So you can look up the value of the Q of the total charge of these two elements, and also total charge of the uranium, and also you can find out the total mass of the two elements and the uranium. So you can find out all this value. So just plug all this value into this formula, and you can see that the final value is negative 36%. So it means that total potential energy is actually decreased by 36%.